Hello, I'm JB Baker. I'm the VP of Product Management and Marketing here at ScaleFlux, where we're focused on computational storage and silicon. It's my pleasure to have with me here today someone who you're very likely to know or at least know of if you've been involved in enterprise data storage anytime in the last couple of decades. Uh, Andy Walls, fellow and CTO of IBM Storage Group. Welcome, Andy.
Thank you, JB. It's a pleasure to be here. I thank you very much for that introduction, and I look forward to speaking with you today.
All right. Well, and then the topic today is computational storage. That's what we're going to be chatting about. But just to level set the audience, we're not going to spend a lot of time on what is computational storage today. There's lots of other introductory content out there, including a great video that Andy did just a few months ago. So instead, what we're going to do is go just a bit deeper into computational storage, where it stands today, and where it's headed in the future. That sound good?
Sounds good.
All right. So the first question that comes up quite a bit when we start talking about computational storage and move beyond what is it, is what functions should be done where? What should be done on the application server versus, say, in a storage array controller or possibly in a NIC or a DPU or some other kind of accelerator, or what should we push all the way down to the drive? So I'll let Andy give me your thoughts on that first.
Yeah, that's a good place to start, and perhaps one way of looking at it is uh, where does the function do the most good? For example, if you need something close to the data, then having it in the SSD makes a lot of sense because if you think about most SSDs, and this includes our FlashCore module, the amount of bandwidth inside far exceeds the amount of bandwidth that is available. All right. So if you need functions that involve scanning the data or filtering the data or searching or things like that, there's a lot of extra bandwidth that the SSD can use without impacting the overall performance. Whereas if you do that at a higher level, JB, you might be limited in the amount of PCI Express bandwidth, the amount of memory bandwidth. And so making looking for where the bandwidth makes sense is a good place to start. All right. And when you're looking at perhaps things that would run closer, that would make more sense to run closer to the CPU, then it's what if I am doing an application that uses that could conserve CPU horsepower, that could conserve memory bandwidth, um, without impacting the performance that much, then it makes sense to put it up in the up in the server. So it can depend on the configuration, can depend on the application, but I think you need to look at where there's bandwidth available and where it can do the most good from overall performance.
Yeah, those are great points. It's a you hit on without saying directly. It's the what are you trying to do with this offload to begin with? Are you trying to reduce network traffic? Are you trying to make the compute node more efficient? Are you trying to take advantage of extra bandwidth in the NAND off of the PCIe bus in the storage array? What you have to look at, what are the goals that you're trying to achieve for a given situation, and then that's going to tell you where you should put that function.
Yeah, that's even a better way of saying it. These days, there's even with faster networks, JB, it's still we find congestion on the network, right?
Oh, absolutely. Yeah.
Especially when you're in a cloud centric world where you might be going out of the data center for bandwidth, and so being able to reduce that bandwidth can make the difference between running for a few minutes for a batch job or an application or an AI workload, or a few hours or a few days, right? So you
Yeah.
need to look at where your pinch points are and how you can reduce that with computational offload.
Yeah. And then it's what, as you're looking at how do you take advantage of those pinch points, or open them up a bit, it's also for that function, what are the expectations around it? Does it need to be something that runs at full line rate? Does it need to be many gigabytes per second of throughput? Or is it more of a background task that
Right.
it's fine if it takes a while, and maybe it's okay if it's got a less than or a lesser power CPU or processing engine, because it's fine that it took a long time.
Well, and it might have a lesser power CPU, like if you offload it to SSDs, but you have more of them, and you
That's
can
true.
be running in parallel. And I always like to think of it this way. We've gotten in the habit of doing everything with software, and yet we're running out. Moore's law is we're having difficulty with Moore's law, as we're not getting the increase in the number of cores without having to pay more. So you really want those cores and those GPUs doing what what makes the most sense for them. All right, they are critical resources, and to have them doing things like a lot of branch instructions to look for the right data, for example, is kind of a waste of time. Why don't you go down into your storage or into your SSDs, or at the network with various offload, and do your filtering there, so that you're bringing the data that the CPU can then start doing real analysis on, right? That's an example, JB.
Yeah, yeah, and as you mentioned there, it's about the parallelism, and computational storage, while a newer term in the industry, at its core, it's another way of referring to distributed compute,
It is.
or domain specific compute.
It is. That's right. It amazes me in my 40 years in this industry, how often the same thing kind of comes up with a different name, right? and, and
Yep.
and without criticizing anybody, it's because the technology for that object now has gotten to the point where it can do more things. You couldn't do this with hard disk drives, JB. All right,
Right.
it just you couldn't.
No,
The
I
flash.
thought you were going to throw me under the bus as a marketing guy and say it's those marketing people that keep renaming everything.
We needed to get to the point where SSDs and stuff were there and mature enough where we could now do some real processing in the storage, right? So,
Yep. Yeah. Um, Hey, so next layer deep on that is, we talked a little bit, but maybe what kinds of functions do you think make the most sense at each level, and maybe from the storage array perspective with the products that you've been delivering already?
and we're really at the beginning stages of this, JB. Or although we've been talking about computational storage for several years, we've really just begun. Um, and one offload that we've done for about 6 years is compression. All right, and we call it transparent compression. We have it down in our flash core module, and the storage stack knows nothing about it except a control path that's looking for how much space you have left and that you don't run out of space. But in the data path, there's no, it's completely transparent. You send the data, the RAID sends it down to the FlashCore module without knowing anything about it. The FlashCore module takes the data, compresses it, then unreads, decompress it, and that really helps the overall performance. Because what are we doing? Well, we're offloading the processors from having to do compression and garbage collection and metadata management. All right. And those three things kind of illustrate what I'm talking about. Why not have the CPUs do something more valuable than just running through compression algorithms, when those can be done in the SSD pretty easily? right? You do it. You've done compression in yours as well, right?
Yes, yeah. On the and so on the compute node side, where we've had most of our deployments, and ScaleFlux has designed the computational storage drive with our own custom ASIC in there, where we've put a hardware compression engine right into the flash controller.
That's right.
Because that hardware engine is vastly more efficient at doing compression than a general purpose x86 processor in
And
terms of
not only
bandwidth
that,
and power.
and not only that though, if the CPU does it, all right, now it has to deal with the fact that the data has shrunk, right? And
Hmm.
now it has to have a log structured array like an SSD already does. It has to do garbage collection. It has to do remapping, and it's further away from the data, so it's less efficient. So now you have garbage collection on top of garbage collection. All right. And
Yep.
so having that in the SSD, whether it's like you say in the compute or in the in the storage, has been great. Now encryption's been done actually. You could call that computational offload, JB, and that's been done before we even called it computational storage. Right?
Yep. Yeah.
Those,
That's kind of a
those
de facto feature in the SSDs or enterprise
that's right.
SSDs now.
That's right. At least for encryption for data at rest.
Right.
So that those two are just no brainers. To go beyond that, uh, one looks at again what can be done efficiently in an SSD or in a storage array better than what can be done in a CPU. And I think something that is that hopeful. I haven't seen it done yet. You guys have some IP around this too. Is the idea of filtering for
Hmm.
database acceleration, JB.
Yep.
And the only downside of that is that you need APIs and interaction with the software to some extent to make that work, right? So,
Yes. Yeah.
yeah,
So that, yeah, that definitely jumps ahead into, what are some of the challenges. But that's because we did do the predicate filtering, but it's when you design that and put it together, it has to be tightly tied in with the application. And so it's not like I can just take what we did for one database and say, oh, you use a different database, we can go ahead and plug that in and you can just automatically use it. So that
well,
transferability of that work gets to be a challenge for its broad deployment. Whereas like the
yeah,
transparent compression that we both deployed, you don't have to do anything from the to the application.
that's right. That's right. A- Another area, and by the way, whenever you impact software, that's the challenge, right? That's the challenge to adoption. That's why I tend to like to call software impossibleware because it's hard to change. No offense to our software friends watching, it's just it takes a lot of cooperation in order to change that. One thing that I've been working on a lot here, JB, is the whole idea of coexisting, and that is having assists, not necessarily doing the whole thing down in the SSD, but sending data that is more easily uh, noticed down in the SSD and analyzing that data, aggregating it, if you will, and then sending it up to a server or storage controller for further analysis. And an example of that is in the whole area of ransomware detection. All right,
Yep.
where you're going to be looking at how compression has changed and how is data being encrypted or are accesses changing so that it was this way, but now there's been somebody that's gotten into the network and started to access differently. So you can imagine an SSD or a storage controller has ready access to how that data was compressed, how it's compressed now, can do calculations in band, and send summaries, if you will, that can then be analyzed, looked at even by machine learning models, and then have inference engines that run maybe in the server that can take that data and look for patterns. So that's an area that I'm focused on.
Yeah, we've had similar discussions with some of our prospective customers around, hey, can we, because one of the core things that we see that's a common thing in these ransomware attacks is suddenly they grab your data and they encrypt it, right? And
Yeah,
they've got the keys, and they're holding the key, and you've got to pay them to get the key back to your data. So seeing that uh, sudden change in the type of workload or the compressibility of the data is a good flag that, hey, something may be awry here,
yeah,
if it's not an
yeah.
expected thing. So.
Well, and imagine using AI here, all right, where I can train using normal patterns, right? So you run some normal workloads and you see how that data looks, and then you run ransomware or ransomware simulators, and you train the model to look for things that are different. And that's where AI can I think really start to make a difference. And this whole idea of passing statistics back, I think, goes beyond just ransomware detection. Imagine if the SSD is keeping track of latencies and keeping track of other kinds of performance parameters and keeping statistics on that and doing some analysis and letting the system know, your workload has increased. We suggest that you do some migration to another SSD or to another storage system, or even to do that automatically. There's a lot of things we can do here with the data that an SSD or a storage system, JB, it doesn't have to be
Mhm.
just at the SSD. The data that it's collecting about the storage is valuable and can be used for AI ops, if you will, and for helping to manage and helping to improve the storage in the data center.
Yeah, yeah, that's some very interesting ideas to get implemented there.
Yeah.
Um, hey, so still kind of going down the same lines, what you called it impossibleware instead of software, but I'm going to say, what is it?
No
What is it?
offense to our software folks.
Well, hey, it's hard to change code. I understand that.
That's right.
But how do we get the software and applications to become computational storage enabled or computational storage aware? Um, yeah, I've engaged with many software vendors, and they like to be hardware independent or
Yeah.
agnostic, and but there may be just minor changes that can be or tweaks that can allow them to take full advantage of devices like what you offer and what we offer.
Yeah. Well, that's an interesting item to discuss, and I'm sure you have some good ideas there too. I think it starts with standards, JB, right? And having APIs and standards that the software providers themselves can approve, can can really use, and therefore make it agnostic, right? The way that you make things hardware agnostic is by complying with standards. Why can we attach different SSDs into a server? Because they're complying with a PCI Express standard and NVMe, right? And that allows you to use different
Yeah,
SSDs.
yeah,
So you have to do the same thing here. You have to have standards that that minimize the change that the software folks have to make. I think they need to be weighted toward keeping the software as similar as possible, and and have those standards such that hopefully they could work across multiple databases and such. What do you think? It,
yeah. I same kind of thing. It definitely starts with the standards because that way it makes it where if somebody bought, say, a ScaleFlux computational storage drive and then they wanted to switch to the IBM Flash Core module or vice versa, they could without having to further change the application as long as we're both complying with, hey, how do you access that transparent compression capability?
Yeah.
or other computational storage function. For some of the applications, I've kind of felt like we get a bit in the catch-22 of there has to be enough um, deployment of computational storage hardware for the software
Uh,
guys to care, but then they
yeah.
don't, they kind of depend on each other. And that's where having either, we contribute to the open source community for some of the databases to say, hey, here's a module that allows you to take advantage of transparent compression or predicate filtering, um, or getting into a collaboration with a major end user who they carry enough weight to then be able to do that application modification.
That's a very good point, JB. So it starts with standards, but that doesn't completely remove the 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 roadblock of the code that needs to be written, and there needs to be a a a business case, if you will, or a reason to do it. And I think your approach there of making the first inroad into the open source. We've done this with Ceph to a degree. We've gone in and said, it probably will be good in the future for Ceph to have compression, and so we've written some code to help determine the compressibility of drives. All right, where you are on out of space conditions and such.
Mm-hmm.
I, I think just using that as a crude example is the same thing if we're talking filtering for databases or whatever. If you can get in with open source that can then be taken and collaborated on, I think that's a great idea.